equation. So first we're going to look at x here and try to solve for it. So we're going to go underneath the assumption that every car that enters must also leave. So like there's no parked cars. And what I'm going to say is that these cars that are entering must be equal to these cars that are leaving. So I express this right here and I find that x is equal to 400. My next step is figuring out the other values. So x travels here and then it either goes into y or 100. And y can be expressed as just that. X minus 100 is equal to y. Okay, so then our next one is going to be z. Z can be expressed as y plus 250 because they both go into this point, which then feeds into directly to z. So then I wrote that down there. And then for w, I decided that it would be easier to look up here. There's 100 that's going into this 260, right? So the other part of that 260 must come from here. So w must be equal to the 260 minus that 100, which I expressed down here. I do a little bit of rewriting down here to figure out that. And then over here, I'm going to take my 250 for that x, and I'm going to rewrite it down here with the x's and the w's and all that. And the reason I'm doing this is when I put it in the matrix, it's easier for me to solve. So I'm just going to highlight them for which one they are, and then all the values match. I know this is probably redundant, but that's okay. And then when I take this matrix and I put it into Sage, which basically takes it and puts it into its reduced f, and then we get these amazing numbers. And what these numbers represent is the possible values of x, y, z, w. This here is equal to our w value. This up here is equal to our y. This up here is equal to our x. And then, what color did I make z? I made z this color. And that is equal to our z. And then, since there is no values without a home, there is only one solution for this equation. X, y, w, and z all have one solution. There's no free variables. And yeah, they'll have a little happy home. So for this one, I started it out just like the other one. First, we're going to say 650 is going into y. It can either go into y or x. So I'm going to express this as y. So y is equal to 650 minus x. Okay, and now x can go into there, but it's coming from this 650, goes into x, or it goes into y. So I expressed this here as the 650 minus the y is equal to the x value. For z is the combination of this x going into it and this 150 expressed there. And then w is this z value minus this 220. And then that goes up, which is exactly written there. I then rewrote them all so that way they it's easy to put them into matrix form with the values. And then they got put into that form with the leading coefficient being the one put into the matrix. And then when I put it into Sage, it got me the reduced echelon form. And then in this is actually our free variable. So our very last variable, which is our, so this is going to be our w value because of this being the very last one. I am marking it in purple. So w is equal to a free variable, which means that there is many solutions, infinitely many solutions, but not really because we have to understand of this context of cars. So in this same equation, we are assuming that none of the cars can be stopped, broken down, disappear. So w can be between 0 and 580 and has 580 solutions, considering they cannot be a decimal point answer because of it being a full car. For the smallest amount of traffic possible through x, I've got these nice handy equations. So what I'm going to do is I'm going to look at the graph, and I'm going to say that y has to be, the max y could be is all 580. That's with w is equal to 0 as my other. So the max y could possibly be is 580. Okay, let's look at z. I also want to maximize z. I want to maximize y and z for this equation. The maximum z could be is 220. I want all of that going to that 220. So what I'm going to do is I'm going to have my z max be this 220 and my y max be this 580. And then I'm going to use that to conclude that my y minimum must be 0 because my z max is 220 So then I'm going to plug that in here and get my x max is 70. And this makes sense looking at the graph, because if I had 580 go from the y, that would leave 70 for this x. And then 70 plus the 150 is 220. So W could equal 0, but x would need to be 70.